The History Channel now returns to robots.
Like an infant learning to walk, robots had taken their first awkward steps. But like a teenager learning to drive, true freedom would only come once robots could travel great distances on their own. In 1979, Hans Moravec brought the knowledge from his Stanford cart to Pittsburgh and joined forces with a team from Carnegie Mellon University to create mobile robots. Carnegie Mellon researchers had been working on their own cart called the Intelligent Mobile Platform, or IMP. This hallway navigator borrowed autofocus sonar technology from Polaroid cameras to map its world. It scanned its environment as a lighthouse would, but sonar proved to have severe limitations.
You can't see very far away. It has a problem if you have a smooth surface, the sonar just hits the smooth surface and bounces and never comes back. And so you may think that there's nothing there when in fact there's a nice smooth wall.
Moravec's next project with the Carnegie Mellon team, called Uranus, used specially designed wheels to overcome some troublesome technical issues.
Uranus exhibits that unique ability to move instantaneously in all directions, not just like we drive a car, but also to move laterally, spin on a dime, or to pirouette so it could turn while moving. And we couldn't solve the parallel parking problem, so we made machines that could move like chess pieces that could execute the kind of simple plans and models that we could create.
With the advent of microcomputers in the mid-1980s, scientists dreamed of finally creating a fully autonomous mobile robot. But even using state-of-the-art technology, they required a specially rigged truck dubbed the NavLab 1. The robot vehicle needed a separate four-cylinder engine to power 4 computer workstations, a supercomputer, its vision systems, and an air conditioner. Graduate students sat in the back to control the equipment, but the big truck was driving on its own. Originally, few people believed that NavLab would ever travel over 5 miles an hour and then be able to stop.
The NavLab 1 typically ran at about a walking speed. In fact, my son was born at the same time that we built the NavLab 1, and we had a contest that when he was crawling, it was moving at a crawling speed. When he learned how to walk, it was moving at a walking speed. When he learned how to run, it was moving at about a running speed. He finally got a bicycle, and then the NavLab 1 was moving at about the speed he could ride his bicycle.
NavLab ultimately exceeded 20 miles per hour, but children on bicycles were just the kind of object that its vision system had difficulty handling. NavLab was equipped with stereo video cameras and a laser rangefinder, but it still had great difficulty telling the difference between changes in terrain. The blue truck was replaced with NavLab 2, a U.S. Army Humvee fitted with an impressive new vision system known as Alvinn. Alvinn is what is called a neural network program. It's actually capable of learning to drive. Alvinn is shown the road through a video camera while a person does the driving. After about 5 minutes of this learning process, Alvinn takes over and continues driving on its own. NavLab 2 eventually reached driving speeds of 55 miles per hour. Then, in 1995, the NavLab team decided to try a new streamlined approach with their robot vehicles.
We said, look, rather than putting all the processing power and all the electrical power on board that we think we might possibly need, let's go the other direction. Let's figure out how much power is available just through the cigarette lighter. And let's limit our processing to whatever we can get off of the vehicle as unmodified.
NavLab 5 was a stock minivan, complete with laptop computer and multiple television cameras for front, side, and rear vision. Alvinn was replaced by a more sophisticated neural net system, Ralph, which could handle lane changes and heavier traffic. In 1996, Thorpe and his students sent NavLab 5 on the No Hands Across America drive, in which it made its way from Washington, D.C. to California. Ralph did the driving during 98.2% of the trip. The newest NavLabs have reached a point where the distinctions between robot and car have all but disappeared. The computers, radar, and cameras are now virtually undetectable. And that, Chuck Thorpe believes, is the whole point.
Oh, if you take it to show it to my son's 6th grade class, they're disappointed because it doesn't look so impressive. But that's really the idea, that computers are disappearing, the robotic stuff is disappearing. It's more and more of a comfortable environment that just feels like a car, a very smart car that can help you drive, but very much a familiar environment to be driving.